Hello, welcome to another video of heuristic algorithms. In this video we're going to demonstrate how to use Excel, more particularly the solver in Excel. So the first thing that we need to do is to make sure that we have the solver available. Chances are in your computer you already have it, but if you don't, you go to the Windows Office icon and you select Excel options, and you will have a menu that looks like that, and you select add-ins, and you will have the solver add-in there, and you can go ahead and install it by selecting go, and here you have some options. I have not installed the statistics program, so that's what I'm going to do in my computer, and also I'm going to install the solver add-in. You only need to have the solver add-in. Just for my own interest, I will bring Internet Assistance, VBA, and ToolPak, but you don't need any of those. All you need is the solver add-in. So I'm going to click OK, and it's preparing the setup, and I'm gonna pause the recording because all you have to do is wait a few minutes, so it makes no sense for having you waiting on this. And after a few minutes the process is finished, and we can now go to data, and you will see the solver option under the analysis window. So when you click on that, you have an option there or a menu that has certain characteristics. What we need to specify here is if we want to maximize, minimize, or get a particular value in our objective function. And here in this region we're going to decide which ones are our decision variables, and we're going to specify the constraints in this window here. So first we're going to populate our model with the parameters that we need, and then we're going to come here and make use of solver to find an optimal solution. So let's say that these two cells, I'm highlighting that with a yellow color. Let's find something more subtle there. Those two cells in yellow are the decision variables for x1 and x2, and we're going to assign some coefficients for the objective function associated to these decision variables. And it's nothing fancy really. It's if you take an operations research course, then this is straightforward. And all this does, it's a linear relation to compute an objective function, and that objective function is just the value of the first decision variable times the first coefficient plus the second decision variable times the second coefficient. As it is right now, we don't have any values, or the values are 0 for x1 and x2, and the objective function is 0. Of course, if I add a couple of values there for the decision variables to be, say for instance 1 and 2, we would have 2 times 5 plus 1 times 4 add up to 14. And we're going to add the coefficients for the constraint also with respect to those, or for those decision variables. Let's say that we have as constraint 7 and maybe 10, and what this means is that 7 times x1 plus 10 times x2, whatever that is, should be less than a particular value. Let's say that that value is 100. And also we can add yet a second constraint. We can have many constraints. Let's say that the other parameters are simply 15 and 12. Should not be more than 120. And now we need to set up an equation to compute how many we're actually using. So this would be 7 times x1 plus 10 times 2, and the total resources consumed is 27 out of a possible 100. And in the same fashion, we have 15 times x1 plus 12 times x2, and that gives us 39 units consumed out of a maximum of 120. And now we are set up to compute which combination of x1 and x2 in a linear fashion would maximize the objective function. So we go again, data solver, and we have this window. We want to maximize which cell. We're trying to maximize, it's already there, it's F8. Okay, and all I need to do is to select that cell. By changing which cells, I now have to select the two cells, and I'm changing the decision variables only. And then I'm going to add, I'm adding the constraints and the cell reference, and I can do all this in a single way. That is, the pattern in general is these cells, G12 and G13, have to be less than or equal to the limits that I have imposed on them, which are cells F12 and F through F13. And those are the only two constraints that I have. I select OK. Everything else is almost ready. I have to go to options and make sure that it's in a linear model, and I am assumed no negative. That means that the values for x1 and x2 are can only take values 0 or larger. And in some models that is relevant, in others model is not. In this model it should make a difference because of the structure of the constraints and the objective function. And now we're ready to solve it, and we press OK. It's solved, and the program is offering to restore the original values or find alternative solution. Or keep the alternative solution that just found. We keep the new solution, and the best solution that we get is to obtain 50 units by using all our resources in the first constraint, and given the way that I computed it, everything was going to the actually both constraints happen to be at the limit there. So let's change the parameters a little bit. Let's say that for the second constraint we're gonna use 15 also, so in such a way we won't be having that luxury of having that point, and we will clearly see how now we have slack here, in which not all the constraint is used, not all the resources on the first constraint are used, and only 80 units are used. But still, the best combination is to keep producing 8 units of x2 as opposed to 10 that we had in the previous solution. So this is a very easy way to use Excel solver, and I'll see you next video.